What's up everyone, welcome back, Patrick here. Moving on to the next example. Here we have to factor this expression 15x to the 5 plus 132x cubed minus 27x. So always with factoring, what is the first thing we check? Can we take out a greatest common factor? Well, notice that all of these expressions, they have an x, and the lowest degree is going to be the x to the 1. So that I could take out. I could also take out 3, right? Everything here divides by 3, so I could take out a 3x at the beginning. So we would have 5x to the 4 plus 132 divided by 3 is what? 44? So we'll have 44x squared minus 9, like that. Right, just took out 3x from all of these expressions, divided them by 3x. And then over here, I'm noticing, let's maybe take this and bring it to the side here. I'm noticing that this follows a quadratic format because I have a exponent for it and exponent 2. Whenever you see like exponents doubling like this, and those are the only variables, so if maybe we saw like an x cubed and an x6, or like an x to the 4 and an x to the 8, right? Whenever you see that kind of pattern in a trinomial like this, lots of times the way you can easily factor this is I could rewrite the x to the 4 as x squared plus 44x squared minus 9, and you could do a change of variable. So I could bring in a new variable, let's call it m, for x squared, right? And so we would end up with 5m squared plus 44m minus 9, like that, right? So it's just a temporary variable just to make the factoring process a lot easier and have us work with a quadratic, right? Like a legit quadratic here that we're used to versus having this degree of 4 polynomial that we have to factor. And then after we factor this, we'll bring back that x squared for the m values. So we just have to factor this. So what we have to do is figure out what are there two numbers that multiply to negative 45 and add up to 44. There it is, right? So that would be negative 1 and 45. Negative 1 and 45, that works. So we could decompose that middle term, 5m squared minus m plus 45m minus 9. And then we could factor out an m from the first two. We could factor out a 9 from the last two. And then the 5m minus 1 is constant. And we're left with the m plus 9, like that. However, we're not factoring in terms of m, right? So what we have to do with these factors now, let's actually go back to our main work here. So we got the 3x we still factored out. This 5m minus 1, instead of writing m, we're going to write the x squared, right? We're going to bring back that x squared. So this is going to be 5x squared minus 1. And then this is going to be x squared plus 9, like that, if we plug in the x squared for that end. And then from here, this can't factor really any further, the x squared plus 9. Sometimes maybe depending on your on where you're getting the questions from, sometimes they'll have like, because this, even though the 5 is not rootable, sometimes they'll treat it as a difference of squares. So they'll have like the square root of 5x minus 1 and then the square root of 5x plus 1. Right? They'll treat this as like a difference of squares, and then you'll have like the x squared plus 9. But usually a difference of squares is when everything is rootable. So if I had like 16x squared minus 1, then definitely that could factor further into 4x minus 1, 4x plus 1, right? But something like this, I guess it depends on your prof if they want you to go further or not. But yeah, either way, that is how you do this one. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.